Welcome to Advantage. I'm Dr. April Strom, and what we're going to talk about today is pertaining to thinking about quantities. This particular video is actually going to be part one of two videos that I'm going to talk about specifically thinking about quantities. So we're going to start with this cylinder here, your typical hydro flask water bottle type shape. So mentally think about filling this particular bottle with water. It's empty in the beginning, and now you're imagining filling this bottle with water. And I want you, when you're thinking about that, to think about two different quantities. One, how much water is now in the bottle, and then what's the accompanying height of the water in that particular bottle, okay? So if you imagine filling this bottle with water, the height of this particular water in here is increasing, and so is the volume of the water in here. Now we're going to be very curious as we do that to graph what is actually happening with those two quantities. So we have a graph here. We're going to focus again on volume of water in the bottle, and I'm going to have this particular quantity on the horizontal axis. And then I'm going to measure against height of the water in the bottle on the vertical axis. And so here, if we attend to the amount of water in the bottle, what I'd like for you to do is consider this axis here for volume to be partitioned into equal amounts. It doesn't matter how much each partition is, but say equal parts, something like this. And you notice I have no quantities. I'm not putting any actual numbers, values on this particular axis because we have no idea how we're measuring this. So here we go. We're gonna think about adding this amount of water to the bottle, and we're curious what would be the accompanying height relative to that amount of water being added. So if I come over here, I think, well, first off, the bottle is empty, therefore no volume, therefore no height. So I have a point at 0, 0 to connect the idea of 0 volume, 0 height together. So we've got a point that we can label and say 0, 0. Okay, we know that as a fact. The rest of the numbers we won't know. So here, if I add an amount of water to the bottle, let's say I'm gonna add, some amount of water, and here I am, in terms of the height of that water in that particular bottle. Then I can map that quantity over here to my graph and say for some amount of volume being added, I have a height that's about this much here. Okay. If I again add that same amount of volume, whatever it is, to this particular cylinder, I achieve the same height back out of that water. So now I have a new height, say about right here. So a new amount of volume being added, I have again the same amount of height achieved from that amount of water being added. So pretend about right here. And I could keep doing that. So imagine playing this mentally in your mind and imagining the volume increasing, and so does the height is increasing. But you want to know in what way is that height increasing relative to those changes in volume. So when I continue adding, and I can continue mapping over to this bottle, for every amount of water I'm adding, that's the same amount as the previous I've added, I'm going to achieve a new height that is the exact same new amount being added as the previous amount from before, and as the previous amount from before. And that just keeps going until this particular cylinder is filled. And so if I do that, I end up with a beautiful, nice linear type function here with this particular graph. Now I put an arrow on here to say that particular quantity, those two quantities can continue going forever and ever, but we know this particular bottle is going to have a top, water is going to overflow at some point, so you probably want to stop this graph right about here to show we know we won't be able to add any more water to that particular cylinder once we get to a certain place. But the idea here is to imagine with this shape of a bottle, I have these two quantities that are being co-varied. They're being co-varied here in such a way that when I increment the volume of water in this particular bottle, I achieve the exact same amount of height in the end. And so then we can call this the constant rate of change. And we're able to get a constant rate of change anytime I have this constant amount of this quantity that is achieved when I'm adding this constant amount of this volume quantity over here. So the next video is part 2 video, and I'm going to change this shape of this particular graph and this bottle so that we can see differences in how the graph comes out relative to the shape of the bottle.